PICUP.io is a website where you can run code in your browser without having to install any software. The free version will allow you to run VPython. Just a word of warning, when you run VPython in a browser, it's actually called GlowScript. So if you go ahead and sign up for your free account, and then we go to the home, you should see a list of courses. Right now it probably only includes the PICUP Virtual Workshop, and so if we go into that, over on the left hand side you will see a navigation window where we can move to some of the different pages that are available inside this course. I've included a reference section that I normally give to my students that kind of gives them some background on VPython if they want to do a little more reading beyond what's within the activities. We're going to go down to the orbital motion activity. This is based off of a PICUP exercise set, two-body gravitation. And one of the reasons we like to use VPython is that there are three things that allows us to do that are very handy. The first thing is it draws three-dimensional shapes on the screen very easily. Second thing is it has vectors built into it, and so VPython allows you to do vector math quite easily. And then lastly, graphs are pretty easy in VPython as well, and so if you're graphing quantities as objects are moving, that's a pretty easy thing to do. So to go ahead and create an object is actually surprisingly easy. All you need to do is go ahead and type in the name. So let's go ahead and create a sphere, and this left-hand side is the code input. The right-hand side is going to be the output, so you'll type everything you want, all your commands over here, and see what's going on over here. Click on the Run button, and we'll see that sure enough we get a sphere. Let's go ahead and create a box. Now these guys are going to be overlapping. Actually, I think the box is inside the sphere, so let's try moving this. And you can see the box is kind of sticking out of the side. Incidentally, if you hold down the right mouse button and move the mouse around inside this window, you can actually rotate the view around. So when you create these shapes, you can specify different properties. The position uses the name pose. When you create a quantity as a vector, you need to specify explicitly that it is a vector by using vector or vec. Another thing to point out, these parentheses are used to denote the arguments of a function. So anything that's inside this set of parentheses is associated with this sphere, and it kind of gets passed to the commands that are drawing that sphere. The color property can also be set. Just to note, the standard way that the colors are defined is color dot, and then the name of the color, color.blue, color.green, color.black, whatever you want. That's just kind of the naming convention. And so we can go ahead and change the positions. Let's go ahead and create a box. Let's call it this. Now, here's a note on naming variables. Variable names cannot start with a letter. They can contain numbers. The only special character that you should use is the underscore. So for example, let's say I'm going to create a box. I'm going to call it my cube, and let's give it the position, say -2, 0, 0, and we'll give it the color green. Another thing to watch out for is to not use commands for your variable names. So if I was going to call this box my box, but it's better to use a different name just so you don't run into issues further down the line. So if I go ahead and run the code, sure enough I get a nice green cube there, and we can take a look around at what's going on. Now that pose property, that dot position, or I'm sorry, the position, you can access this by adding on dot pose to the end of your variable name. So for example, if I want to change the position after I've created, I can go ahead and set that equal to a new quantity. I can also use that to print off the current value of the property. So print myball.pose. We go ahead and run it. Down here you can see that it's printing off that current position, and I can go ahead and set it to a different value. Let's do -3, -2, -2, and print it off. And you can see now it's down at that final position. One way that this position command is useful is if we're calculating position-dependent forces, you can use that in an equation. Myball.pose is just a vector. You can see that right here. So you can plug that into any vector equation, and it will give you the results that you want. You can also use this to animate the motion. So for example, if we go ahead and create an object, and we use some sort of a loop where I'm constantly updating the position of the ball. Let's go full screen with this. So we have over here, I create a sphere at the origin just for reference so we can kind of see things moving around. Here is my moving object. And then I'm going to use some variables to represent the maximum amount of time that I want this to run. I need to initialize my current time to 0 and then set some sort of time step size. Now, the format here of the while command is while this is true, while the current time is less than the maximum time, and then we add a colon at the end of that. When you go ahead and hit return, it will actually indent the text one tab or 4 spaces. The structure of Python is anything that is indented is considered part of this loop. And so all of these lines right here are indented. That's going to be part of this while loop, which is going to run numerous times. The rate just tells VPython how quickly to go through this, and so you can speed up or slow down the animation. When you have a while structure like this, it's important that you actually increase your time. If I had forgotten this line, this would end up being an infinite loop, and occasionally students have trouble getting out of the web page when that happens. So it's always important that you update whatever condition you're testing. Now, animating the motion is really easy. All I need to do is change the position at every single time step, and the way to do that is to set the, in this case, my moving ball.pose to some new quantity where it's the original value plus some quantity. Now, this may look a little strange to you if you haven't seen this before, where I have my moving ball.pose on both sides. The way Python handles this is it calculates the right-hand side, and so it's going to use the current value of my moving ball.pose. And then once it's done that calculation, it's going to go ahead and assign it to this quantity over here. So if we go ahead and watch this, you can see, sure enough, the red ball is moving relative to the green ball. So that can be used quite easily for updating that position. Now we can also create other properties and associate them with specific objects. We're not limited to just the commands that VPython has built in. So for example, if I want to create something we're going to call velocity, when I create this object, I can go ahead and give it a new property. This is the name of the property. This is the value that I'm assigning to it. So, for example, let's say I want to give it a mass as well. Let's just go ahead and call it mass and set that equal to 1. I can go ahead and give it a charge as well, set that equal to 1 as well. Whatever physical properties you would like this to have, you can go ahead and create those. Now, VPython doesn't know anything about what mass, velocity, or charge are, but the nice thing is you can use those at a later point in time, and they're tied to that. So for example, my moving ball, if I want to go ahead and update the position, where the new position is going to be equal to the old position plus the velocity times my time step. Notice here that my moving ball dot velocity is now able to access this quantity. I can also use that for changing the velocity, as we'll see in the activity. All right. So to update the positions, what we're going to do is use these two equations of motion. Well, we're going to update the position with the velocity, and then we're going to update the velocity based on a force. And this is pretty easy to do in Python. So here I'm creating my origin again for reference. Here is my moving cube, and now I've given it an additional property, force, in addition to mass and velocity. And so now anytime I type in moving cube dot force, I will have access to this vector quantity. Set that maximum time that I'm going to compare against, initialize my current time to 0, and then set my time step size. In terms of what value to put in here, you typically have to play around with this to see what gives you the results you're looking for. This tells me that this while loop is going to run at 30 times per second, which will give me an animation of 30 frames per second, which is pretty smooth. Again, don't forget to update your time, whatever this check is. That time at some point in time had better be greater than a max time if you want this while loop to stop. So here is the position update equation, where the new position is equal to the old position plus velocity times time. And now here I'm making use of the fact that I can change that velocity property of moving cube to be the old velocity plus f over m times that time step. And so if we go ahead and run this, we'll see that sure enough, our cube is moving off, and it is in fact accelerating. We'll come back to graphing a little bit later on, but in the next video we'll go ahead and start the two-body gravitation.